Alright, so we're trying to do second derivative test. So I got to take the first and second derivative of this function. So x e to the 2x, so f prime. This is a product. I'm going to take the derivative of x, which is 1, leave e to the 2x, plus leave x, take derivative of e to the 2x, which is going to bring a 2 down in front, and then leave the exponential. So that's our first derivative. The second derivative is going to be take derivative of e to the 2x, that's 2e to the 2x. Then I must treat this here as a product again. So derivative of 2x, that's 2. And derivative of e to the 2x, that brings another 2 down. And if we simplify, that's 4e to the 2x plus 4x e to the 2x, which you could really write as 4e to the 2x times 1 plus x. And it's nice to write it this way because I have to set it to 0 to find my inflection points. Now there is no way for an exponential to equal 0. So this guy doesn't tell me anything. I just have to solve the x plus 1. So x plus 1 equals 0, gives us x is negative 1. That's my inflection point. So once again, I do my number line. And then I use my test points. So again, the exponential can't be negative. So I really just care if, or what happens inside of 1 plus x. So plug a negative 2 in there. Negative 2 plus 1, that's negative. And 0 plus 1, that's positive. So I should be able to say concave up from negative 1 to infinity, and down from minus infinity to negative 1. Any questions about that guy? And as always, you can plot that on your calculator real quick. And if we zoom in, we get something that looks like this. Roughly. All right, so I don't see any questions. I'll go ahead and do the next one. So this one we're going to need the quotient rule. So let's find G prime. So I need low times D high minus high times D low all over low squared. Let's simplify that before we take the second derivative. So this is x squared plus 9 minus 2x squared, or minus x squared plus 9 over x squared plus 9 squared. Please do not try and simplify that any further. So let's do G double prime. So I need low times derivative of high minus high times derivative of low. So I'm going to bring this 2 down in front. And then the derivative of the inside of this function is 2x. And then all divide by x squared plus 9 to the 4th. Everybody with me? Anybody still there? Hey, somebody's alive. Good to hear. Guess that's a bad joke. Sorry. Alright, so let's continue. If I use the green marker, can you guys actually see it is the question. So I've got an x squared plus 9, and I've got at least one of them there, and of course I've got one of them there. So every term has x squared plus 9, so I'm going to cancel one of them. Get rid of this guy, get rid of one of these and make that a 3. And then I'm going to get rid of one of those. So now, left behind, I have x squared plus 9 times negative 2x minus negative x squared plus 9. Now over here I'm going to have a 4x, and then all divide by x squared plus 9 cubed. I'm going to go ahead and take out a 2x out of everything. Actually, I think I'm going to take a negative 2x out. So if I factor out a negative 2x here, I'm just left with x squared plus 9. And if I take a negative 2x out, I still have a 2 left behind here. And so that's going to make this plus, and these two things multiplied by 2. So then, all simplified, this is negative 2x times minus x squared plus 27 all over x squared plus 9 cubed. So let me just check that real quick. Derivative of, in our original function, was x over x squared is 9 Then I have to take the second derivative, and I'm going to use a command called together to put it together as one fraction. So it states, let's see, they have 2 times x cubed minus 27x. So if I put this minus sign in there and the x in, that would make it the exact same thing. So our derivative looks good. For second derivative test, we've got to take that, set it to 0, and we also need to find out where it's undefined. So basically, we're setting the numerator and denominator to 0. So I need to solve negative 2x times minus x squared plus 27 equals 0. So this is going to give me x equals 0 from my outside here. And then minus x squared plus 27. Let's solve that. Now, square root of 27, that's going to be what, 3 root 3? And then the denominator, however, if we try to solve the denominator, we're going to get complex, right? Because we'd be solving x squared equals minus 9, and we'd get x equal plus and minus 3i out of that. So those aren't going to help us, so we really just need the numerator. That gives us 3 inflection points, 0, 3 root 3, and negative 3 root 3. So again, number line, 0, negative 3 root 3, positive 3 root 3. And then I just need to test 1, 2, 3, 4 intervals. So the first question is, what is 3 root 3 equal to? So we can find a nice number to use. So square root there gives us about 5.2 approximately. So it's approximately 5.2, which means we could choose 6 out here. We could choose 1 in here, negative 1 there, negative 6 out there. So if we do that, plugging those in, the denominator is always going to be positive because x squared is always going to make any negative number positive. Then you're adding a number and taking it to the third power. So we don't have to worry about it. We just got to worry about the top. So let's actually go ahead and let's multiply this negative back in. So the outside only depends on the sign of the number you plug in. So that would be 2 times negative 6. That number is negative. Negative 6 squared is bigger than 27. This number is positive. So negative times positive, negative. If we plug a negative 1 in, again, negative out here. In here, we're going to get negative, so this is overall positive there. If we plug in a positive 1, we get negative, and if we plug in 6, we get positive again. So, make some room over here, I guess. Concave up from minus 3 root 3 to 0, and also from 3 root 3 to infinity, and then down from minus infinity to minus 3 root 3 and 0 to 3 root 3. So these problems are heavy in that you've got to be able to take a derivative quickly and easily. Then you've got to be able to clean it up with algebra. And then it's some basic arithmetic after that, plugging in numbers, seeing what the signs are, and just defining it to be concave up or concave down depending on that sign. Are we okay with this one? Or any questions? If there's another example one like this to do, it'd be cool. Otherwise, this one was good. Let me look here and see what's left in the packet. I think when we get to the next section, there'll be one like this. So we're going to do curve sketching. I think there's one of each type. There's one there for curve sketching, so we'll have another chance to do it. Just with a little more in-depth. Alright, so I'm going to go ahead and erase that. So far we have done both first and second derivative tests. So the first derivative test tells us whether something is increasing or decreasing. The second derivative test tells us whether something's concave up or concave down. And now we're going to put that together along with a lot of other stuff that we already know how to do to sketch a graph. So this gives us a list of the things that we need to do as we go through the problem. We have to determine the domain. We should compute the intercepts. So let's just make some notes here real quick. Computing the domain, that is values of x you are allowed to plug in. Then we need to compute the intercepts. So we can set x to 0, solve for y, set y 0, solve for x. Then it says determine, should say any symmetry of the function, even or odd. So that is f of x equal to f of negative x, or is f of negative x equal to negative f of x. So this is even, this is odd. Okay. Then find asymptotes. So if it's a rational function and it's undefined, that's where we find the vertical ones. Horizontal ones we can find with the limit as x approaches infinity. Then we can use first derivative test to find intervals of increasing and decreasing. We can also find the local max and mins, and then use the second derivative test to determine where it is concave up and concave down. And with all of that information, we can sketch the curve. So let me go ahead and try this first one. Is that a question? Appears the internet does not like to cooperate.